Well, ladies and gentlemen, to carry on, we'll ask you for a round of applause to Dalila Aguilar. It's control and quality of raw materials. As providers, we have the responsibility of producing raw materials for the animal food industry that should be in a good state of nutrition and conservation. Our next speaker will talk about this last point. So I introduce Dalila Aguilar from CFS, Tresen, counting with 18 years of experience developing operational procedures of standards and continuous enhancements, strengthening the development of documentation, and she has done bacteria trials in conservation. Strong round of applause, please. Hello, everyone. We will begin with conservation of fresh tissues previous to processing. I'd like to begin with a question. To see in what conditions when do you introduce your raw materials into the processing? And it was mentioned previously about the relevance of nutrition quality of our fats and meals and raw materials of the meat, supermarket, which are the main providers of raw materials of animal origin. The industry and yield has been more competitive, and we've seen that with the development to draft procedures, to have enhancements in the equipment.
The decomposition of raw materials, it's a very repetitive topic in the rendering factories. For example, temperature is a very important factor as well at times that they take to be rendered, as well as other factors that intervene, such as not having our process integrated in the same building. And might also happen that even though we have in our buildings the integrated blend of rendering and the processing one, we can take over 8 hours to process this raw material. And this is due to the fact that we want to save energy. So we consider the save in the electric spend and energetic in general, and that's why we take some more time to process that. The use of chemical additives, it's not new, and we've been developing new technologies in order to conserve raw materials. One of them is the chemical additives. We have some others as well, but they are less used. All right. Now we're going to talk about the differentiation mechanisms that we have. We have the hydrolytic and the oxidative. Am I talking too loud? Too loud? No? All right, perfect. Thanks. The hydrolytic will be produced by the action of the fatty acid of the short chain and the presence of humidity, what will cause a diminishment in the percentage, and the percentage of the free fatty acids will increase. We know that the quality factor the quality factor of a free fatty acid is the BGL. And we also have the oxidative, which is the action of oxygen as a free fatty acid with double link that will produce aldehydes and alcohols. And these can be affected by the insaturation of the fat, the storage, the temperature, and some other factors, as well as metals and heat. The raw material that we want to render, in case we want to improve it, in case we have any problems, in this case, I will take the chicken offals as an example. And in here, we can have heart, gut, lungs, and some other components, so to say, but we have to avoid the presence of feathers. These can be considered contamination. So we need to avoid any quantity of feathers with the good practices of manufacturing. What is this composed of? Well, three main components: protein, fat, and humidity. The protein can be between 10 and 23%, fat 10 and 20%, and humidity between 60 up to 65%. What is the conservation of freshness? Well, the fact of delaying the decomposition in a physical or chemical way of material raw, in this case, the chicken offals. How can we delay it? Or how can we aid that the composition is not so fast? Well, we can use physical or chemical means. As I said, we have the formol that the engineer Julieta already mentioned, the organic acids and antioxidants, even mix of those. In case of recollection, it's frequent that we see the storage in a physical way, that we store them in cooling rooms using temperature or low temperatures, but it's not enough. And they can also be there over 36 hours to complete the storage of the truck. So it's something that they can make money with. That's why they do it in a cooling truck. But as I said, sometimes that's not efficient. Sometimes the systems that they have over there to handle the raw material is not the optimal one. Also, as I said, we can do it with chemicals. And here we can have several mixes with formic acid, for example, and also salts. I'll talk a little bit also about the mesophilic bacteria. I know everyone here knows a lot of technical terms, but it's important to remember the action of these bacteria. These type of bacteria are huge indicators that allow us, let's say, identify when we can have contamination or when our processes, our hygiene processes are not ideal. Why? Because when we have a big charge of these bacteria, we can have the presence of pathogens, and they are an indicator of the processes of hygiene. This graphic shows an experiment they did using bactericide. The blue line is the use of the bactericide, and we see how it increased with the pass of times. Let me contextualize a little bit. There were 3 days in which they did the trial without the bactericide, and they took samples at the end. So these were the readings we had in the raw material at the pass of the criba. You stop the test at the 3rd day, and then you resume the test, and then with the same conditions, with the same time of screen, with the same conditions, and we try to reduce the bacteria charge, and it dropped in the 3rd day. That's why it's very important, the use of things that help to conservate the raw materials. What should we do to guarantee that the raw material is in fresh conditions? Or if we have the integrated process, so it's conservated until we have to render it. Well, the conditions of the rendering plant, the suppliers that we have, the times, as well as the correct transportation, and we can also use the conservatives. Why do we mention the conditions of the plant? Because we have to oversee the capacity of our rendering process. We can have a plant in which we can process 100 tons of raw material per day into shifts. What that gives us opportunity to do maintenance. But what happens if we have that capacity, but we're processing 90 tons and not 100, and then we have a layback, and we end up working 3 full shifts, including Sundays? And it can happen that maybe we last months without being able to stop for 2 or 3 hours. So the capacity of the process will be very important. The reception area, and what conditions is it? Does it actually have all it needs to receive all that input? How is the internal cleaning of our plant? If I want to render 100, but I have a capacity of 80 currently, then I will have a delay in the cleaning process. We will give priority to production, but the cleaning system or the cleaning part will be left aside. Or are we just cleaning because we have to, but not to prevent contamination? And that's something we can see sometimes in the transportation chain, how the offals are all stuck together in the transportation means due to the delay of the raw material. And some other consideration we should have is the percentage of AGLs that we use when we have processes in which we have to add some oil or fat, because we don't allow the AGL to drop if we're using a percentage of over 10 or 15 or 20% of AGLs. So if there's some renderer here, he knows that when we try to avoid delays, that can happen. Our supplier can be an internal supplier or an external supplier, because we have some that dedicate to the recollection. And I say that, but it's not simple. It's not easy. There is a lot of struggle in the management of the raw material, and it has to be ideal. How is the area of the product? If we have access and we can say that this is our internal client, and we reach to them and we say, look, I need to improve the quality of my raw material, but I went there and I saw the conditions in which the processing area were not adequate, or the ones that we agreed on initially. So what happens? We say, no, we are from the same group. I had some issues and a lot of excuses, but sometimes our screen is like this. What product that goes through there, it's going to have a low bacterial charge? What kind of product is going to be conservated if I'm not doing a correct separation of liquids with a screen that it's not daily cleaned? So the cleaning process has to be daily and constant. The cleaning system even more, because that dirt is of days and days of accumulation. The time also plays a very important role in the decomposition of the raw material, because we have time to collect, in which maybe I have 8 or 10 times collecting that raw material, and the first one that I collect in the first supermarket or in this first spot, it has those 8 or 10 hours, and sometimes it's not refrigerated. So we are not meeting the requirements. The storage that they use, how long does it take to carry a 24-ton truck if it's cold? Because sometimes they transport it in bags, and we have to load this truck. How long does it take that? The carry from the origin point up to the process point. Let's say we are an integrated group, and I have my raw material that is arriving at the same time that's processed. It doesn't take 5 minutes from the moment the animal is sacrificed, and we separated the offals to the point I get it in my station, but I leave it there storage because I don't have the sufficient tons to start the rendering process. The download of the charge, sometimes I don't have the problem that I don't have the full capacity because nothing is working, so I have to wait 3, 4, 5, sometimes 6 hours after waiting for 8 hours for the product. If we put together all the hours, so what time did we have the input for the processing? And we haven't talked about temperatures. In some nice cities, we have temperatures of 45 Celsius degrees with humidities of over 50%. So yeah, that generates more factors to play against for the conservation of the raw material. The transportation, why is it important? Well, we go back to the same issue. If we have a constant delay in our equipment, trucks that already have the presence of bugs and maggots, that doesn't help a lot. I can add 1,000 things, but I'm not having all the necessary cares of the process that takes me to the raw material to be properly conservated. So we have to have a proper design. Otherwise, I have this issue in which I carry 10 tons and the capacity was of 20, but during the rotting process, the offal got inflated, and at the end, the offal exploded, to put it nicely. So there have been occasions in which I had the experience of seeing how a truck gets to the plant totally overloaded, or how they go on the roads leaking profusely. and it has to be safe transportation. Sometimes we say no, but it's the problem is the trucks. But no, because he's just bringing the load, right? But if there's an accident and there's a leak, then what do I do, right? The conservatives. We need to take care of them. We have to be aware of what we'll be using in the dose, the correct dose, the type of product to each type of raw material or each process, because they will be different. Maybe the dose I apply to a raw material that would last 4 hours to be processed, it's not the same than the one that it's going to last 12 or 18 hours. So the areas that will be dealing with that, it's 25 Celsius degrees, or another one at 45, then it's different the way to deal with it, right? So there are many factors that we have to bear in mind. The application system, if I'm gonna cool it or not, in order to make it safer. And obviously, it has to be more friendly with the user. We already said that we have formaldehyde, and we put that as one of the conservatives that are still used. Up to when, we don't know yet, but they are still used. So we have to try to apply them in a safe way, but we also have developments that can be used that are being less aggressive. Here, there's a graphic of a summary of 2 trials that were made. The first one was with a percentage of AGLs of 18. And there were some adaptations within the plant with some cleaning processes, eliminating some delays. There were some improvements. And it lowered a little bit, but if we don't have any consistency, then we go back to the same problem.
Next one, our goal. The goal is to reach 10% of delay, which is still high, but to have it in averages of 33% reducing to 10% is an achievement. So I was mentioning we have 2 trials. The second is with the treatment of antioxidant with bactericide. They had a trend of approximately 12.5% of average. When we began, we had 12.73, more or less. And sorry, but I can't see properly. We had at the beginning, and what we observed was that as the days went by, there was a reduction in the AGLs, which provided satisfaction because the product wasn't aggressive to the user, which helps us a lot to remove a factor that happens when we use organic acid mixtures, which is disconnect the equipment that is applying the product. So using this product gave us results that were important because we achieved our goal, and that in the second day of application. 0 days considered the day when we began using it. So in the fourth day, we had 7.37. So in conclusion, the development and awareness of providers is a key theme. We must get close to them. They sometimes are our companions, but the conditions we receive our raw materials in must be optimal. Processing fresh raw materials, I'd like to go back to the first one. What difference do you think there will be between processing this and processing that? It's huge. Raw material in this condition will never provide us a 15% of AGL and not even close to 10%. And 3, no way. But the raw material in these conditions, I can still see the form of the product where if I touch this raw material, it has the texture, so to say, original texture of the raw material. There's no comparison. But if I do the adaptations on plant that have to be done, it's simply receiving a reception tray, avoiding all the delays and processing raw materials this way will help us in the gains in the end. So thank you very much.